The last thing that we're going to look at with functions as graphs is just a summary. I'm only adding one extra to definition here, and the rest of it is kind of a review, but this is the format which is going to look like on your test. So I wanted to make sure that you've seen it this way because this is how you'll see it on the test. The one extra definition is trying to introduce zeros to you. We're going to be using zeros a lot this semester, so this is a really good place to introduce that word. Zeros are the value of x when f of x equals 0. Or in other words, the x-coordinate of the x-intercept. So if you can find the x-intercept, you can find the zeros. Let's look at our first graph. First, I'm asked to find the domain. I have one arrow here going at an angle that tells me I'm going up forever, but I'm also going right forever. So when I'm looking for my domain, I'm looking for all the x values. And on my x-axis, how low can I go on my x-axis? Looks like -5 is as low as I can go. And I can go forever to the right because that's what that arrow is telling me. So my domain is -5, infinity. Can I include the -5? Well, yes, I can because my point is closed. For my range, I'd like to know how low I can go, how high I can go on my y values. The lowest y value I see is here at 0, and I can go up forever because that's what this arrow tells me I'm going to do. That arrow keeps going on forever and ever and ever, which leaves me with a range of 0, which is the lowest y value, infinity. Can I include 0? Yes, 0 is closed. The x-intercepts, looks like I have one x-intercept at 3, 0. And if I can find the x-intercept, I can find my 0 very simple. If my x-intercept is 3, 0, then the 0 is the x-coordinate, or just 3. Another way of looking at it is on the x-axis. Where does my graph cross? Right here at 3. So 3 is my 0, and 3, 0 is my x-intercept. My y-intercept is where the graph crosses the y-axis, or 0, 3. And the last thing I'm looking for is values of the function at the given input. In this case, f of 2. When x is equal to 2, y is equal to 3. Or the point 2, 3 tells me that f of 2 is equal to 3. Similarly, f of 3, I have a y value of 0, with the corresponding point being 3, 0. On my next graph, I have two arrows, which I'm going to break up into its vertical and horizontal components. This arrow says I go left forever. This arrow says I go right forever. So my domain must be -infinity, positive infinity. My range goes up forever and up forever, although these arrows don't tell me how low I can go. I need to find the lowest value I can on my function. Looks like my first lowest value is at 2, and then it goes up forever. So my domain is 2, infinity. I'm allowed to include the 2 because it is closed. My x-intercepts, where does my graph cross the x-axis? Well, it doesn't ever cross the x-axis, so I have no x-intercepts. I'm going to write none. If I don't have any x-intercepts, then my zeros also have to be none. I do have a y-intercept. It looks like my y-intercept in this case is 0, 3. And to find f at a particular value, f of -3, I'm going to the x-axis at -3. The corresponding y value is 2, and that's verified by the point -3, 2. And f of -6, I go to the x-axis at 6, and I look at the corresponding y value, which is 3. The corresponding point there is -6, positive 3. Here's the last two examples. For my domain, I have two arrows. This arrow is going up forever, but it's also going right forever. I know a lot of students will like, no, that really looks like it's just going up. But because it's continually coming out, it will continue to go out forever. As slow as it may be going, it does continue to go left forever, and also, in this case, right forever. Which tells me that my domain must be all real numbers, -infinity to positive infinity. Similarly, for my range, I have a down forever and an up forever arrow. So my range is going to be -infinity, positive infinity. For the x-intercepts, and we may have several of these, in this case we do, my graph crosses the x-axis at three places, -2, 0, 1, 0, and 2, 0. You just list all three of those intercepts. Once you have the x-intercepts, I like to jump down here to the zeros and fill in my zeros as well. Because if you get the x-intercepts correct, you better get your zeros correct, because the zeros are just the x-coordinate of my x-intercepts. All the values of x where my function crosses the x-axis or where f of x is equal to 0. My y-intercept is where the graph crosses the y-axis at 0, 4. F of my function at -1. Go to my -1 on my x-axis. The corresponding y value is 6, verified by the point -1, 6 on the graph. F of 0, I go to 0 on the x-axis, and I look up or down to the point, which happens to be at 4. So f of 0 is equal to 4, and I know that by the point 0, 4. On this last problem, the arrow on the left is continuing to go down forever, but also left forever. Whereas the arrow on the right is only going right forever. You know that because of the asymptote here. The asymptote tells you that the line gets very, very, very close to the asymptote, but will never ever cross it. To find the domain, my arrow is pointing left forever and right forever, telling me that my domain is -infinity, +infinity. Whereas my range, looking for my y values, I'm going down forever, but I'm not going up forever. The highest the value can be stops right there at +5. So my range is -infinity, 5. Am I allowed to include 5? And the answer there is no. The graph gets infinitely close to the asymptote, but will never ever reach it and will never ever cross it. So we are not allowed to include 5 because he's an asymptote. So I put a parenthesis there. The x-intercepts, it looks like the graph would cross here at -6, 0, which tells me that my 0 is -6. I have a y-intercept at, looks like a little past 4. So we're going to call that 0, 4.2. That's just an estimation. I'm not trying to trick you or anything. If you put 4.3, I would absolutely accept that. Next, we're trying to find f of -2. At the x value -2, I have a y value at 4. And lastly, at the x value of -5, I have a y value at 2 because of the point -5, 2. So in this section we discussed the basics of functions and their graph. We talked about functions as sets. We've talked about functions as equations and functions as graphs. Finding the domain and the range, the values of functions, the x-intercepts of functions, and the zeros of functions.